Hi there. In part A, finding the probability that randomly selecting 3 people from 6 men and 3 women, so 9 total, will result in selecting 3 women. Well, the probability of 3 women, the likelihood that the first selection is a woman is 3, but out of a total of 9. Now, of course, if we're selecting women, we won't be replacing them once someone has been selected. The next probability is conditional. So under the condition that we've already selected a woman, out of the 8 remaining individuals, there are 2 women. That could be the second selection. And under the condition that we've already selected 2 women, of the 7 remaining individuals, there is only 1 more woman to select so that we get 3 women. So, very good. If you want to calculate this probability then, it's good to calculate this as a decimal because you're going to describe the likelihood of this event in part B. So here we go. 3/9 times 2/8 times 1/7. This is a relatively small likelihood, 0.012. And that's the whole point of the next part of the question. Based on your answer to part A, is there reason to doubt the manager's claim that the 3 individuals were selected at random? And the answer is most certainly yes. So you would want to write your answer to part B in context, but the reason that we can doubt, now we can't prove that it was not random selection. It's possible to randomly have selected 3 women. It's just that it's not particularly likely. It will only happen 12 times out of 1,000. So your answer here is yes, we have reason to doubt the manager's claim because the likelihood of choosing 3 women is very small. Of 3 women being chosen randomly. Is quite small. That's not an event that's particularly likely to happen. So the third and final part of the question then, an alternative to calculating the probability is to conduct a simulation. So here we are rolling a die. Each die represents one of the 3 people selected to participate. So for each die, rolling a 1, 2, 3, or 4 represents selecting a man. So 4 out of the 6 options, or 2/3 of the time, we will select a man with that die, and that matches 6 out of 9. There were 6 men out of 9, so that is also 2/3. Rolling a 5 or a 6 represents selecting a woman, so that's 2 options out of the 6. So that's 1/3, and of course 3 out of 9 is also 1/3. So after 1,000 trials, the number of times the dice indicates selecting 3 women is recorded. Well, here's the problem though. Does this correctly simulate the random selection of 3 women? And the answer is no. And here's the problem. Each die gives an independent result. Each die gives an independent result. So when we roll these dice, the action is as if we are replacing the man or the woman as they are selected. So this essentially, these dice represent selection with replacement. But we know that that's not really what would happen. The actual probability should be calculated without replacement. So the roll of the dice simulates a probability with replacement. But the actual scenario would not include replacement. The actual probability should be calculated without replacement. Essentially, if you look at this, every die has a 1/3 shot. So a 5 or a 6, that's 2 out of the 6 possible outcomes. Every die has a 1/3 shot of selecting a woman. But if you look at the way the calculation is done, it is true for the first selection there is a 1/3 chance of selecting a woman. But the problem is the second and the third die will also indicate a 1/3 chance of selecting a woman second and third, but that's not what happens when we do not replace. So the probability is no longer a third here, it's a fourth. And here the probability is 1/7. So the second and third probabilities, these are not independent of what happens with this first trial right here. So the actual calculation is done without replacement. If the likelihood is 1/3 for each woman, then we are acting as if we are replacing the woman after we select the woman, and that's not really what would happen in practice. So another way to describe this is with the word independence. So we are acting as if all of these trials are independent when we use 1/3 for the likelihood of each woman being selected at each point in time. But these are not independent of one another. This second probability depends on what has already happened here. This third probability depends on what has already happened with these first two trials.